Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL online course. Today is lecture 3 and where I will try to cover tire construction and its specification. The first thing which will come to our mind is why required to use a tire. So, I will cover in details about the tire construction, types of tires, tire terminology, specification of tire. Now, the key points are the carcass, beads, crown angle, aspect ratio, tire specification, and finally the overall tire diameter. We use wheel and a ground vehicle to fulfill certain objectives. Objectives are to support the weight of the vehicle, to cushion the vehicle when riding over surface irregularities. Then third one is to provide sufficient traction for driving as well as braking. Then the last one is to provide adequate steering control and directional stability. So these functions are efficiently done and effectively done by pneumatic tire. So if you look at the right hand corner, the tractors are therefore generally provided with wheels, pneumatic tires. So what is a pneumatic tire? It is an annular toroidal shaped inflatable envelope made up of an elastic material. So there are different types of tires like bias ply tire, radial tire, bias belted tire, but all these tires they have some common components like tread, which is tire tread, then carcass, then beads, sidewall, and the last one is optional. Optional in the sense a belt is provided, it may not be provided. So I will discuss in detail about first the bias ply tire, then I will switch on to radial ply tire, then in the last I will discuss about bias belted tire. So in this figure, as I said, whether it is a bias ply tire, radial ply tire or bias belted tire, all are carrying certain common components like tread, then carcass, then beads and sidewall. So what is a tread? How it is going to help us? The tread is the toughest portion of the tire which transmit your tractive force and steering forces etc. While in contact with the soil. Then comes your carcass. This is the most important structural element of a tire. It comprises of layers of cords of high modulus of elasticity materials, and they are anchored around beads which are made up of very high strength material, steel wires. These cords are encased with a matrix of low modulus rubber compounds, maybe natural, synthetic or metallic composition, and they run in different directions. Different direction in the sense, in case of a bias ply tire, I will show you in detail. They run from one bead to other bead in diagonally. Diagonally in the sense, it is making an angle with the circumference of the center lines of the tire circumference. So, center line of the tire circumference means if I so this is the one center line, and this is the these lines are chords. So they are making an angle. So that angle is called crown angle. So this angle is called crown angle. The crown angle decides two things: what will be the type of cornering behavior, what will be the type of riding quality. If crown angle is low, then cornering properties are better, but the riding quality is very rough. If if the crown angle is more, then riding. Cords are made up of natural, synthetic or metallic composition, and they are anchored around the beads. Okay, so the two adjacent layers of cords, they run in opposite direction. That means they overlap in a diamond shape. One cord is in this direction, other cord is in this direction, so like that. So basically, there is a diamond shape here. When they, in other words, we call it as crisscrossing. Okay. Because of that, what happens during operation, when there is a load, there will be deflection of tire, and this diamond shaped portion is getting deflected, elongated. So that creates a kind of action where there will be wiping between tread and the road, so resulting in good amount of rolling resistance. Okay. So the beads, carcass, tread, and the carcass and bead, there will at the side of that there will be a side wall. So this is the constructional features of a bias ply tire. Now coming to the constructional features of radial tire, how it is different from bias ply tire. So now you look at the radial tire. Here the cords are, carcass is there, cords are there. Then in addition to this, there will be a belt, and on the top of the belt there will be tire tread. So the cords here which run from one bit to other bit, they are at crown angle of 90 degree. So that is the advantage. Advantage means it gives a better riding ability. Then these several layers of cords are of high modulus of elasticity, usually steel or higher strength material fitted under the tread. Okay. So this is, I am talking about the belt. Now the cords which are run from one bit to another bit, they are of little lesser high modulus of elasticity as compared to the cords which are present in the belt. Okay. The cords in the belt laid at a crown angle which is lesser than the crown angle of the cords which are provided in the carcass. So crown angle of the carcass is around 90 degree, whereas crown angle of the cords which are present in the belt, this is of around 20 degree. So because of that, because of this belt, the tread is stiffened. So when there is flexing of tire during operation, the tread remains relatively stiff. So the sidewall becomes deflected, and there is a probability or a chance that there could be damage to the tire when it is operated in a severe conditions like stones are there or stumps are there. So those are the severe conditions that may affect the tire. Affect in the sense it may damage the tire. Then the advantage over bias ply tire is there is a gain in fuel efficiency, there is a gain in wheel slippage. Gain in wheel slippage means reduction in wheel slippage to the tune of 6 to 14%. Then comes our bias belted tire. in case of a bias belted tyre, in addition to the cords which are provided in the carcass of a bias tyre, there will be a belt which is made up of higher modulus of elasticity, and this is provided in between the tread and the carcass. So that means it is partly bias ply tyre and partly radial tyre. So it gives stiffness to the tread. So the wiping action is reduced. So the rolling resistance is reduced as compared to bias ply tyre, and the wear of the tread is also reduced because of the stiffness. And the rest of the things, that means the carcass where the beads are provided, and the carcass, the layers of cords, they run at an angle, crown angle, which is around 40 degree. So all those other components remain same as that of bias ply tyre, but only an addition of belt has been provided so that it gives extra rigidity to the tyre tread. So thereby what happens now, there will be reduction in tread wear and there will be reduction in rolling resistance as compared to conventional bias ply tyres. Now after knowing in details about the constructional features, the next thing is what are the different terminology associated with a tyre, whether it is a bias ply tyre, whether it is a belted tyre, whether it is a bias belted tyre. The terminologies remain same in the sense it has a section width, it has a section height, it has a overall diameter. So all those things we are going to discuss in detail, and in this figure you can see where I have indicated the different sections like section width, section height, flange height, then rim diameter, then overall tyre diameter. So in the bottom of the figure, if you look at, there is some deflection. Deflection is shown here. So during operation, what happens, because of the weight, the tyre gets deflected, and the deflected height is lesser than the section height, and deflection depends on many factors like what is the material of the tyre, what is the type of tyre, like whether it is a bias ply tyre, whether it is a radial ply tyre, or whether it is a bias belted tyre, and it also depends on what is the inflation pressure. It also depends on what is the soil condition. So deflection of the tyre will reduce the rolling radius. That means it will reduce the tyre radius, and thereby the rolling radius is reduced. Now, what is the section width? It is the width of the new tyre, including 24-hour inflation growth and normal side walls, but not protective side reefs, bars or decorations. And section height, it is the distance between top of the flange to the top of the tyre tread. So one of the important aspect of a tyre is aspect ratio. What is that? It is the ratio of section height to the section width, and it is measured in percentage. Then, as I told, static loaded radius, it is the dimension measured from section center line to the ground when the tyre is under load. That means if I draw a tyre here, this is when it is not loaded. Now when I load it, there will be deflection. So this is your reduction in radius of the tyre. So static loaded radius means from this point to this point. Okay, so this is static loaded radius. Now overall diameter, it is defined as the rim diameter plus twice the section height of a new tyre, including 24-hour inflation growth. Now rolling circumference is the distance travelled in one revolution of the tyre under maximum load and inflation pressure for that particular tire on a level paved surface, that is, it is on a hard surface. So this is a little bit of different dimensions or different sections which are discussed. Next I will try to find out how the tire is specified. There are two terminologies I have used. One is nominal rim diameter, the other one is rim diameter. The difference is if you multiply 6% of the, if you add 6% of the nominal rim diameter to the original rim diameter, that becomes your rim diameter. That means 1.06 times nominal rim diameter will become the rim diameter. Now, if you know the rim diameter, if you look at this figure, if you know the rim diameter, which is indicated from this point to this point, then I add this section height here, h, on both the sides, then it becomes the overall diameter. If you do not want to do like this, then you add rim diameter plus twice the aspect ratio, a product of aspect ratio and section width, because the tire is usually specified by certain numericals. Like if you look at this slide, you can see this tire, if it is a bias ply tire, it is specified by a number like 13.628 or 16.928. So what does it mean exactly? 13.6 refers to tire section width and 28 refers to nominal rim diameter, and in the bracket 12 means ply rating. Okay. So now 13.6, the unit is in inches, and 28, the unit is also in inches. So if you want to find out the diameter, then you need to know the section height. So section height is not given. That means the aspect ratio is to be used here. So usually the aspect ratio is taken as 0.75 if it is not specified. So if it is specified, if you look at the right side figure of the tire, 13.628, very clearly written, 13.6-28. So there is no mention about the aspect ratio. So here we assume the aspect ratio as 0.75. So now 13.6. So first I have to find out the rim diameter. So 1.06 times into 28 into 28 plus twice of section width 13.6 into aspect ratio, I take 0.75. So this you will get in inches. So diameter will be obtained in inches. Now you can convert into centimeter or millimeter or meter, whatever. Now if you look at the specification, tire specification, radial tire, it is mentioned like 18.446. So 18.4 R46. So the difference between bias ply tire and radial tire is, in bias ply tire there is no alphabets, whereas in radial tire standard system you can see 18.4 there is a alphabet R46. So 18.4 is again the tire section width, which is in inches, and R represents that the tire is radial, and 46 represents nominal rim diameter. So, and you can follow the same rule, whatever I mentioned here, 1.06 times the nominal rim diameter plus twice the section width into aspect ratio. So that will give you diameter of the radial ply tire. But in a metric system, the radial ply tire is specified as, you can see the numbers 480/80 R46 155 A8. So there are good amount of numbers. So the first number 480 represents the tire section width in millimeter. 80 is the aspect ratio, which is, no, this is not millimeter, this is in percentage. Then R is the radial tire. Then 46 is the nominal rim diameter, which is in millimeter, and the number 155, that represents load index. That means it is a load index number which represents maximum load the tire can carry at the rated inflation pressure. And A8, this is a symbol for speed, which indicates the maximum speed for which the load rating is applicable. A8 usually refers to 40 km/h. So this is how we can specify a tire. So the only difference from the outside you can know is whether it is a radial tire, whether it is a bias ply tire. If R is there, then immediately you can say that this is a radial tire. If R is absent in that specification, then immediately you can say that this is a bias ply tire. Ply rating. This is a very important parameter which indicates the index of tire strength. It does not represent the number of layers of cords which are present in the carcass. Before World War II, when the cords are made up of cotton bodies, during that time, number of ply rating means if it is a 12 ply rating, that means there will be 12 cords passing in that carcass. But nowadays, it is not the number of plies, it is the strength that indicates. 8 ply can carry the strength of 12 ply rating. Okay, so that is the difference. Then the second one is load rating. Previously, what happens now, the tires are rated by actual number of plies used in the tire to carry the vertical load. But nowadays, an 8 ply rated tire may have only 6 actual plies, but it can carry 8 ply load rating. So, originally the ply rating of radial tire and bias ply tire for loads and inflation pressure, they were equivalent. Whether it is a radial tire or bias ply tire, their load carrying ability and inflation pressure, they are equivalent. But now the Tyre and rim association, they have increased the radial load by 7% over the equivalent size bias tire. And they have also indicated another component, that is a star rating, to take care of the variation in inflation pressure. So what is star rating? The Tyre and rim association, they created a star rating system for radial tires to denote the rated inflation pressure for maximum rated load. If a single star is there, that means the inflation pressure, maximum inflation pressure it can carry is 18 psi. If 2 stars are there, then it will be 24 psi. If 3 stars are there, then it will be 30 psi. That each addition of star increase the inflation pressure, maximum inflation pressure, by an amount of 6 psi. So, in brief, what I can say is, this lecture I tried to cover the details of constructional features of the tire, how they are specified, and how to calculate the overall diameter of the tire. So, these are the books which can be referred to give more input to your understanding. Thank you.